Greetings, my curious friends. I am Albert Einstein, and today I invite you to embark on a journey through the mysteries of the universe. Tell me, what if I told you there is a place where the very fabric of reality collapses, where nothing, not even light itself, can escape? A place so strange that even time loses its meaning. This, my friends, is what we call a black hole. An invisible giant lurking in the depths of space, bending the laws of physics in ways that defy our intuition. But what exactly is a black hole? How does it form? And why is it impossible to escape its grasp? Let us explore these questions together. Black holes, the most enigmatic and captivating objects in the universe. These cosmic monsters are regions in space where gravity is so strong that nothing, not even light, can escape their pull. But despite their reputation, black holes are far from being holes at all. They're more like the ultimate traps, warping the fabric of space-time itself. The birth of a black hole begins with the death of a massive star. When a star runs out of fuel, it collapses under its own gravity, and in some case, this collapse leads to the formation of a black hole. What happens next is truly mind-bending. At the center of every black hole lies the singularity, a point where gravity becomes infinitely strong and space-time breaks down. It's a place where the laws of physics as we know them cease to make sense. Surrounding the singularity is the event horizon, the point of no return. Once an object crosses this boundary, it's doomed to be pulled in forever. The event horizon itself isn't a physical surface, but rather a boundary marking the limit where escape becomes impossible. Anything beyond this, be it matter or light, is irretrievably lost. But black holes don't just destroy, they play a vital role in the universe. Supermassive black holes, found at the centers of most galaxies, including our own Milky Way, are key to galaxy formation and evolution. They affect the movement of stars, the distribution of matter, and even the flow of cosmic gases, shaping the universe as we know it. Incredibly, black holes can also sing. This occurs when matter falls into a black hole, creating gravitational waves, ripples in space-time itself. These waves have been detected here on Earth, offering us a way to observe black holes indirectly. Through the detection of these waves, we are now able to study the invisible and far-off realms of the cosmos. The most mysterious aspect of black holes is that they challenge our understanding of time and space. The closer you get to a black hole, the slower time appears to move relative to the outside universe. It's as if the black hole is a gateway to another dimension, a place where the rules of our reality no longer apply. Let's break it down into simpler terms. Imagine you're standing in front of a giant invisible vacuum cleaner, but instead of sucking up dust, it pulls everything, planets, stars, even light, toward it. This is a black hole, a region in space where gravity is so powerful, nothing can escape its pull once it gets too close. The closer you get, the stronger the force. It's like walking toward a waterfall. You get closer, and the current gets harder to resist. Eventually, at a certain point, you can't escape at all. That point is called the event horizon, and it's like the point of no return. But how do black holes form? Well, they are born from massive stars, much bigger than our sun, that have burned through all their fuel. Think of a star like a balloon filled with air. The balloon stays inflated because there's a balance between two forces: the pressure of the energy pushing out from the star's core and the gravity pulling everything inward. But when the fuel runs out, the star can no longer keep itself from collapsing. It's like popping that balloon. The core of the star suddenly collapses in on itself, creating a tiny, super-dense point with so much mass packed into it that it forms a black hole. These black holes come in different sizes. Some are relatively small, only a few times the size of our sun, but they still have the power to pull in anything that comes too close. These are called stellar black holes. On the other hand, we have supermassive black holes, which can be millions or even billions of times the size of our sun. These giants are often found at the center of galaxies. Our Milky Way galaxy has one such supermassive black hole, pulling and shaping everything around it, including the stars and planets. These supermassive black holes can control the motion of entire galaxies. Now, let's talk about something crucial when it comes to black holes: the event horizon. This is the boundary around a black hole, and once you cross it, there's no coming back. Imagine standing at the edge of a waterfall. The water is rushing down with such force that if you fall in, no matter how hard you try, you can't swim back up to safety. The current is just too strong. That's similar to what happens at the event horizon of a black hole. At this point, the gravity is so intense that not even light, which moves faster than anything else in the universe, can escape. Light is what lets us see everything. But once it gets too close to a black hole, it gets pulled in without a chance of bouncing back. It's like trying to shine a flashlight into the black hole. You wouldn't see anything because the light would be swallowed whole. Once you cross that event horizon, you are trapped in the black hole's grip forever, unable to escape. There's no second chance, no way to fight against the pull of gravity. Everything inside this boundary is lost to the black hole, including time and space as we know them. Now, why is it that nothing can escape a black hole, not even light? The answer lies in the incredible strength of gravity near the center of the black hole. The closer you get to the center, the stronger the gravitational pull becomes. Imagine you're standing on a trampoline and you place a heavy ball in the middle. The fabric of the trampoline sags under the weight of the ball, creating a deep dip in the surface. The closer you get to the ball, the harder it is to climb out of the dip. In fact, if you get too close, you might not be able to get out at all. In the case of a black hole, the fabric we're talking about is space and time itself, which gets stretched and warped by the immense mass at the center. The black hole's gravity bends space-time so much that everything inside it, planets, stars, even light, is pulled toward the center with no way to escape. But what about light? After all, light moves faster than anything else in the universe, right? Well, even light can't escape the black hole's pull. It's like running at full speed towards the edge of a cliff. But the faster you run, the more the ground beneath you shifts, pulling you back in. The speed of light is simply not enough to outrun the immense gravity close to the center of the black hole. So, no matter how fast something moves once it gets too close, it's trapped. The warping of space-time is so extreme that escaping becomes impossible, no matter the speed or strength you have. Now let's venture into the heart of the black hole. What exactly is inside it? Well, at the very center of a black hole lies a point known as the singularity. This is where things get mind-bending. The singularity is a place where all the mass of the black hole is compressed into an incredibly tiny space, so small that it has infinite density. Imagine squeezing everything, including the Earth, the Sun, and the entire galaxy, into a space smaller than the tip of a pin. The laws of physics, as we understand them, can't explain what happens here. It's as if the normal rules of reality break down completely. Time and space become so warped that they no longer behave the way we expect. But that's not all. Scientists and theorists have proposed some fascinating possibilities about what might lie beyond the singularity. One idea is the existence of wormholes. These are theoretical tunnels or shortcuts through space-time that could potentially connect one part of the universe to another. Some even suggest that black holes could be connected to other parts of the universe via these bridges. Another possibility is the concept of white holes, the opposite of black holes. While black holes suck everything in, white holes would theoretically shoot things out, spewing matter and energy into space. While these ideas are still just hypotheses, they open up intriguing questions about the nature of space-time and whether black holes might be gateways to other parts of the universe, or even other universes entirely. Now, let's ask a dramatic question. Could anyone survive falling into a black hole? The answer is probably not. Once you approach the black hole, something truly strange happens, a phenomenon known as spaghettification. As you get closer to the black hole, the force of gravity becomes much stronger at your feet than at your head. This difference, called tidal force, stretches your body in unimaginable ways. It's like if you were standing in the middle of a giant, invisible stretch of taffy. Your feet would be pulled toward the black hole much more strongly than your head, causing you to stretch out, becoming longer and thinner. In the end, you would be torn apart before reaching the event horizon. But what would it look like from the perspective of the person falling in? As you fall closer to the black hole, you'd experience time and space warping around you. To you, everything might seem to slow down as you approach the event horizon. Time appears to stretch, and light would be distorted. You would likely see the universe outside become more and more red-shifted, as the light from stars and galaxies is stretched to longer wavelengths. However, from the perspective of an outside observer watching you fall, things look very different. As you approach the event horizon, it would appear to them as though you're slowing down and freezing at the edge, never actually crossing it. To them, your image would grow dimmer and redder, gradually fading away, because the light coming from you would be stretched out, losing energy as it tries to escape the black hole. So, from their point of view, you'd seem to get closer and closer to the event horizon, but you'd never quite make it. In short, falling into a black hole would be an experience no one could survive, and both the falling person and the observers would witness two very different realities. Black holes are not just a figment of science fiction. They are very real, and they're out there in the universe, shaping the cosmos in ways we're only beginning to understand. From creating the structure of galaxies to influencing the movement of stars and even time itself, black holes are powerful and mysterious objects that play a central role in the universe's story. As we study these cosmic giants more and more, we start to see that they're not just destruction and darkness. They are also a key to understanding how space and time work, and perhaps even how the universe itself works. And who knows, perhaps black holes are not just the end of everything, but the beginning of something new. What if they're not just cosmic vacuum cleaners, but actual doors, portals to other realities, other universes, or alternate dimensions? The possibilities are endless, and as we continue to explore the mysteries of black holes, we may unlock secrets about our universe that we never thought possible. If you found this fascinating, make sure to subscribe to the channel for more deep dives into the mysteries of space and science.